Now, a proportion is anytime you set two ratios equal. So a proportion will always have two fractions that are equal to each other. And the way to work with proportions, if you're asked to find a missing value or an unknown in a proportion, is it turns out that the cross products are always equal. What I mean by that is if you multiply at an angle, the A times D and the B times C, those things are always equal to each other. So for example, in part A, if I want to figure out what x is, I'm going to start by setting the cross products equal. So that means 20 times x has to equal 17 times 36. Now I'm going to have to figure out what 17 times 36 is. So I have my work written out over here, and let's see, I end up getting 612. So 20x equals 612. And then to finish, I'm going to divide by 20. To help me with the division, I'm going to do some reducing here, just because I noticed both of these numbers are divisible by 2. 612 divided by 2 is 306, and 20 divided by 2 is 10. And then anytime you divide by 10, it actually takes the decimal and it moves it one place to the left. So 306 divided by 10 is 30.6. And that's my final answer. The same idea holds even if the problems get more complicated. In this next example, I'm going to do the exact same thing. I'm going to set the cross products equal. So 1 and 1/10 times x has to equal 11/7 times 2 and 1/3. Now to solve this, I'm going to take all those mixed numbers and change them into improper fractions. 1 and 1/10 is 11/10. 2 and 1/3 is 7/3. Then I'm going to multiply the numbers together on the right-hand side. I'm going to reduce, the 7's cancel. So 11/10 x equals 11/3. Now, to get rid of this 11/10, technically we need to divide both sides by 11/10, but dividing by a fraction is the same thing as multiplying by its reciprocal. Notice if I multiply the left-hand side by the reciprocal, by the fraction flipped, the 10's cancel and the 11's cancel, and I'm just left with a 1x. So that's exactly what I'm going to do on the right-hand side. I'm going to multiply by the reciprocal, 10 over 11. Now the 11's cancel, and I am just left with x equals 10/3. You can leave your answer like that if you want, or you could write that as a mixed number. 3 goes into 10 3 times with 1 left over, so you could write that as 3 and 1/3. Okay, one more example. Let's do one that has decimals in it. Exact same process. We start by setting those cross products equal. So negative 0.4x equals negative 7 times 2.4. I'm going to start by figuring out what 2.4 times 7 is. And then let's see, because there is one digit after the decimal, that answer has to have one digit after the decimal. Oh, I lost a negative somewhere. Oh, this was supposed to be a negative 0.4x. Okay, so negative 0.4x equals, this is going to be a negative 16.8. And then to finish, I have to divide both sides by negative 0.4. That means I'm going to have a positive answer. To do the division, I want to clear the decimals in the denominator, in the bottom. I have to move the decimal one place to the right, and so I'm going to do the same thing in the numerator. Technically what I'm doing is multiplying the top and the bottom by 10 to move that decimal or clear the decimal. So now I'm left with 168 divided by 4, and it is going to be positive because I'm dividing two negatives. 4 goes into 16 exactly 4 times. Oh, and 4 goes into 8 exactly 2 times. So my answer is 42. Now proportions, allow us to solve some types of application problems as well. And so I'm just going to show you an example of an application that can be solved using a proportion. In example 5a, it says, on an architect's blueprint, 1 inch corresponds to 6 feet. Find the length of a wall represented by a line that is 4 1/3 inches. So if you want to set up an application problem using a proportion, I think the most important thing to do is to keep track of the units. So in each of these problems, there should be two numbers that go together. And that's the 1 inch corresponds or goes with 6 feet. So you're going to take those two numbers and you're going to put them on one side of your proportion. And I would keep track of those units. I like to write them down, because then when I write the other side of the proportion, the units have to be the same. I have to put inches on the top and feet on the bottom. And that tells me where does the other number go and where does the x go. So 4 1/3 inches, the unit is inches, that has to go on the top. And then the thing I don't know is the length of the actual wall. That's going to be my x. And when I find the length of that wall, the answer should be in feet. So now that I have the proportion written, I can set the cross products equal. 1 times x equals 6 times 4 1/3. I'm going to write the 6 as a 6/1, and 4 1/3 is the same as 13/3. And then I can multiply straight across. Well, there's a common factor of 3 here. I might as well cancel that out. And I'm left with 26/1, or 26 feet. All right, let's look at one more example of a proportion. So this problem says the daily dosage of a medicine is 60 milligrams for every 20 pounds of body weight. If a patient weighs 170 pounds and he is to receive this dose every 8 hours, find the amount of medicine he should receive in each dose. All right, so let's start by writing our proportion. The two numbers that go together are 60 milligrams and 20 pounds. The other number they give us is 170 pounds. Because the units have to be the same, the 170 pounds has to go on the bottom, and so x will go on the top. Now I'm going to set my cross products equal. 20 times x has to equal 60 times 170. And I got 10,200 when I multiplied 60 and 70. And then I'm going to divide by 20. And to reduce, I'm actually going to cancel out a factor of 10. That'll help me with the division. Now I have 1,020 divided by 2, which should be 510 milligrams. Now, this isn't my final answer in this problem. They told me that the 60 milligrams was the daily dose. So this 510 milligrams is the daily dosage that this patient should receive. But if this person is taking medicine every 8 hours, in 24 hours, they are taking 3 doses of medicine. And so we want those 3 doses to add up to the 510 milligrams. So to figure out how much should each dose be, I am going to take 510 and I'm going to divide that by 3. 3 goes into 5 once with a remainder of 2. 3 goes into 21 7 times with no remainder. 3 goes into 0 0 times. And so my actual answer to this problem is 170 milligrams. So if they take 3 doses of 170 milligrams, that should add up to 510 milligrams. That's it for this lesson. As always, please let me know if you have any questions on this material.